Hi, everybody. I'm Matteo from Bournemouth University. There, my wife and I have a small perception laboratory. But this work is in collaboration with the University of York, with Claudio Guernera and Tao Chen. It's about color constancy. It's our ability to perceive color appearance rather stable despite changes in the color of the illumination. We are investigating which are the actual computations applied by our brains to achieve constancy. Typically, the computations take two steps: estimate the illumination and discount it. However, these are evaluated based only on the first step, because the information we have available is typically photos of real scenes like these ones, in which we know the color of a surface is only under one illuminant, so we don't know how that would be under a neutral illuminant, but we know the color by placing a probe. However, because spectral information is lost because we have 3D spaces, the problem is ambiguous, and in fact, there will be multiple ground truths. So the way we overcame it is to do physically based simulations of thousands of scenes, for which we have the scene under a colored illuminant, the scene under a neutral illuminant, which will be your target, and the estimated scene after discounting the illuminant. So we can use a number of algorithms, the most popular, and compare the two methods. And what we see is that the choice of the method, evaluating based on the illuminant or evaluating based on the full scene, makes a difference in the performance of the algorithm. And also what you see is that if you consider the whole scene, the shades of gray and white patch and gray edge are the ones that perform best together with gamut mapping, whereas gray word performs terrible, whereas the situation changes if you consider only the illumination, for which the gamut mapping performs well. That's physical. We did a fast perceptual experiment, a simple perceptual experiment, in which we measured for a selection of scenes color constancy for our participants. So participants had to adjust the color of a circle here on a gray background to match the color of a sphere rendered in the scene. The sphere is white, they were not told. So perfect constancy would be when they make this neutral or white, and zero constancy would be when they make it the same physical color as this. So we correlated this with the performance of the algorithms, and the performance is measured as an error. So the negative correlation implies good prediction, that the algorithm predicts well what people do. So you get the best results based on the illumination. So when you compute performance based on the illumination and not on the whole scene, and the best algorithms are the white patch, the gray word, and their combination given by shades of gray. So the simpler, the better. Simpler way to estimate and simpler algorithms. So probably constancy is simpler than we thought.